Calculus!
This is AP Calculus Self-Check 3.2, or an AB Calculus, of course. So let's go over the answers really quick. Number 1, E, 2, E, 3, D. Then we're going to the back. 4A, 5B, 6A. All right, and of course, jump around through the YouTube video to find the answer that you're looking for. So, number 1, we have a graph of f prime. We're looking for intervals where f is decreasing. So, I'm asking you this. What is the definition of f decreasing? If you thought of f prime less than 0, then you are correct. All right, so on a graph of f prime, next question, what is f prime? Is it height, slope, or concavity? If you answered height, you are correct. So this is now interpreted as where is the height less than 0? Where is the height less than 0? Well, it's less than 0 between here and here and here and here because it's below the x-axis. So you need to say between 0 and 2, between 0 and 2, and between 4 and 6, between 4 and 6. And if you've been freaking out that they have square brackets, it's because AP tests, they don't actually care that much. It should be 0 to 2, like that with parentheses, just because you can actually be decreasing at the time that you're at 0 because your derivative is 0, and we all know that. And then you'll have your union 4 to 6. So that would be Mr. Sindell's way of doing it, but that's too accurate, I guess. All right, let's do number 2. So we have a graph of f prime again, and we're looking for points of inflection. How many do we have? Very similar to self-check 3.1. All right, so what's your definition of inflection point? Definition of inflection point is where f double prime does what? Yep, it's a sign change. Oop, lag sign change. I wish I had my tablet. My handwriting on my mouse is horrible. All right, so I have a graph of f prime. So what is f double prime? Is it height, slope, or concavity? If you answered slope, you would be correct. So we're looking for a slope sign change on this one. So I have a positive slope here, a negative slope here, which means I have a slope sign change here, 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 and here. Count them, 4. E. Number 3. Now we have another graph of f prime, and we're finding the original graph of f. So we're going backwards now. Here's f prime. Which one of these is f? So let's go ahead and analyze the information. F prime sign change, we know that's going to be relative extrema, and more specifically, we can tell what type of relative extrema it is. So for example, the height down here is negative, and the height up here is positive, which means I had an F prime change from a negative to a positive. That is the very definition of what? If you said minimum, you would be correct. And then over here, we had no relative extrema because there is no f prime sign change, although it is a critical value right here. A critical value meaning that f prime is equal to 0. The height was 0 here. We did not have a minimum or a maximum. So what we're looking for is a graph that has a minimum at this x equals -2 and nothing else, no minimum or maximum elsewhere. Another thing that helps you with this problem is that this is a positive cubic. So I'll write that down to positive cubic. And if I'm going backwards, then I should have a positive quartic. A fancy way of saying if it changes directions once, twice, then somewhere over here I'll have the possibility of changing directions 3 times instead of twice. 1, 2, yep. All right, so let's look at this one. I have a minimum at x equals -1.5, so it's not A. Minimum doesn't exist in B, no minimum there. So we have it narrow down between D and E. There's a minimum there and a minimum there. The problem here is that this has another minimum here, which should have shown up on the graph of f prime, so right away we can get rid of E. And just by process of elimination, we've gotten D. Let's talk about why this is a positive quartic. So it's always the possibility of changing direction. It doesn't quite change direction here. It continues up positive, but you can kind of tell right about here at x equals 1, which correlates to this x equals 1 up here, that the slope here goes to 0 because f prime up here is also 0. F prime equals 0 is where, yeah, the slope is 0. So I change direction once, twice, and then thrice to come back up towards positive infinity. And because both the end behavior goes to positive infinity, it is a positive quartic, or a positive polynomial of degree 4. All right, on to number 4. The graph of f is shown, which could be the derivative of f. So now we're going forwards. This is f. Which one of these is f prime? And again, you just always have to go back to your definitions. So what definitions do we have to work with f prime? Well, we have some f prime sign change, and we know more specifically if it goes from a positive to a negative or a negative to positive, that's going to be a minimum or a maximum. Here's a graph of f. That's clearly a maximum right there. So I'm going to be using the definition of f prime going from positive to negative is my max. So I'm looking somewhere down here for relatively like that x coordinate. I should have a height that goes from a positive to a negative, because again, if these are graphs of f prime, height is going to represent f prime. So there it is. So at that x coordinate, I have a height going from a positive to a negative. That's why the answer is A. If I come back over here, I have no, it doesn't go through the x-axis, so it's not B. C has a relative extrema here, but this is a minimum because it goes from a negative to a positive. So if this graph were reflected over the x-axis, then it could have been C, but it's not. D, I have no idea what's going on here. You have double relative extrema, but we only had one here, so it doesn't make sense. And E, it kind of makes sense, right? Maybe you could see how this one would be a quadratic and you took the derivative and it's a linear function, but that's not quite the case because you still have this possibility of a minimum that's looking to be a minimum out here if it were to go back up this way, and a minimum that's going up out this way. The main thing here is that you will have a critical value at this location because the height is, or the slope is approaching zero. So you should have the height approach zero on the graph of f prime. So that's the difference between A and E. They are really, really close, but the correct answer is A. Finally, or not finally, we have 5 and 6. So number 5, all f prime, and f double prime are negative. So which of the following could be the graph of f? So that means it needs to be below the x-axis. If f of x is negative, that means I have negative values. So that one has positive values. Everything else is below the x-axis. Perfect. Now we look at f prime. F prime needs to be negative, which means the slope needs to be negative for all values of x. So it needs to be negative everywhere. Well, look right here. This one's positive. No, it's not that one. This has negative slopes everywhere. This has positive slopes everywhere. So it's not C. This one has negative slopes everywhere. Good. And so we're between B and D at this point. So the kicker here is where f double prime is negative. So the concavity has to be negative everywhere. Well, look here. It's negative here, but it's positive here. It's concave up over here, so it's not D. This one is the only one that is concave down. All slopes are negative, and all the heights are negative. It is B. Number 6, our last problem, final self-check of the day. So we are looking for relative maximum, not relative extrema, relative maxima. All right, and this is a graph of f prime, so I'm going to ask that definition again. What is relative maxima? F max. That's where you have f prime change from what to what? Yeah, you're right. It's positive to negative. So on the graph of f prime is what? Is it height, slope, or concavity? You're correct. F prime is height. So I'm looking for where does the height go from a positive to a negative? Well, the height goes from a negative to a positive there. That would be a minimum. It goes from positive to positive there. Definitely not what I'm looking for. This is an inflection point. We have a height that goes from a positive to a negative. So there's 1. We counted 1. And there it goes from a negative to a positive. So again, that's a minimum. We only have 1. The correct answer is A.